Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our webinar today, where we'll address some of the challenges surrounding industrial cybersecurity. My name is Scott Siphon with Moxa, and I'll be your moderator. First off, I want to go through a couple quick housekeeping items. If you have any questions related to our topic during the webinar, please submit them through the questions pane, and we'll address them during the Q&A at the end. Also, we'll be emailing a recorded version of the webinar tomorrow to everyone who registered, so please be on the lookout for that. Okay, now let me introduce our presenters. First off, we have Rich Wood, who is Moxa's Product Marketing Division Manager. Rich brings over 25 years of industrial automation industry experience, with the last 5+ years heavily focused on security in the OT space. Alongside Rich, we're joined by Richard Koo, who is Senior Vice President of Commercial IoT Security Business and Market Development for Trend Micro. Richard brings over 28 years of experience in cybersecurity across multiple roles. Thank you to both of them for being here today. With that said, I think we're ready to go. Let me hand things over to Rich Wood to kick things off.
All right, thank you, Scott. So before we get started, just wanted to do a quick introduction to Moxa and Trend Micro. Just a few fast facts about Moxa. We are a leading provider of edge connectivity, industrial computing, and network infrastructure solutions for enabling industrial connectivity. We've been in business a little over 30 years, connecting over 50 million devices. And currently, we have market leadership, #1 position for serial connectivity and #3 for industrial Ethernet. In addition to that, Moxa's got numerous global awards for design, quality, as well as an employer. From a product standpoint, we talked about edge connectivity, industrial computing, and network infrastructure. So the products we provide solutions in are serial connectivity, connecting legacy devices, industrial gateways, I/O connectivity, video. We have a line of embedded computers, both Linux and x86 based, as well as a full line of industrial Ethernet products, switches, routers, wireless, and network management. Our core markets are smart manufacturing, rail transit, power distribution and transmission, oil and gas, intelligent transportation, and marine. With that, I'd like to turn things over to Richard to do a brief introduction of Trend Micro.
Thank you, Rich. Yeah, so a little bit about Trend Micro. We are a company that's been around for about 30 years, founded back in 1988, and we're a public company headquartered in Tokyo. We are one of the largest cybersecurity company, in the world, and we serve different customer segment from consumer to small business to mid-size and enterprise customer. And we have about 35 business units around the world. And over the last 5 years or so, we have been very focused also on developing cybersecurity solutions and strategy for the industrial environment as well. And this is a good conversation that we're going to have together with Rich and myself. So thanks, Rich. Next slide. Yeah, and also from a market leadership position perspective, right? Trend Micro actually have been recognized by Gartner, Forrester as the leaders in terms of endpoint security. And our solution have been proven and tested by many of the third-party organizations like avtest.org, being one of the best cybersecurity for protection on the endpoint. We also are the market leader in terms of cloud security, right? So any of you out there, using Azure or AWS or Google Cloud, in any of those cloud platform, we actually secure many of those environments as well. And then on the networking side, Trend Micro actually have been recognized by NSS Lab as the top score in terms of breach detection across the different type of our customer environment. So this is just a little bit information about who we are. Thank you.
Great, thanks, Richard. So here's our agenda for today. We're going to start with some industrial cybersecurity market trends, just kind of catch up on what's happening in the market. Then we'll move into a little discussion about some of the differences that we see between how you would deploy security from an OT perspective versus an IT perspective. We'll talk about some of the top gaps and vulnerabilities in industrial control systems. We'll introduce some of the common standards we see a lot of our customers deploying, and then talk about some practical first steps to secure your industrial control system. So with that, let's just jump right into some of the industrial cybersecurity trends. So the two big things that we see consistently over the last few years that have impacted security from an operations technology standpoint are the Internet of Things, or industrial Internet of Things, where we're seeing more and more industrial devices connected directly to the internet. And the other main one where historically control systems might have been isolated from the enterprise IT systems. More and more we're seeing them connected, and the IT systems looking to draw more and more data from the factory floor. And obviously, as you connect those two, you've got more chances for vulnerabilities, and what happens in one area could potentially impact the other. So we're gonna reference this study from SANS quite a bit. This was done earlier this year for a survey of the state of OT, or ICS cybersecurity. And what it found this year was that more than 50% of the people surveyed saw OT or ICS cybersecurity as a significant risk to their company's overall risk profile. And that's likely a result of the growth in incidents attributed to foreign nation states or even organized crime, where disruption and destruction was the main objective. So industrial attacks have actually been around for quite some time, but they've certainly been on the rise since around 2010, and where a lot of the early attacks that we saw back in 2010, 2012, were really focused around critical infrastructure, and in many cases were conducted by nation-state organizations. We're starting to see over the last few years where we're seeing much more hacking activity targeting industrial automation in factory environments and more commercial institutions. So with that, I would like to turn this over to Richard, and he can talk a little bit more about some of the specific attacks that we've seen over the last few years and the impact that they've had.
Yeah, so as Rich mentioned, right, historically, the type of cyber attack in the industrial have been around for many, many years. However, these are some very good examples where we have seen a significant impact in some of these customer environment, right? And the first one, I think, as you all have here or have seen all over the past in 2010, is the Iran Stuxnet centrifuge attack, right? And this was very much more of a zero-day vulnerability that was taking advantage using a USB device, right, and to compromise some, cement equipment in this, centrifuge environment. And the result was that there are many centrifuges, right, in the environment were out of control, right, during the operation, and it caused some significant damage into some of these, environment. The other one that it's a good thing to refer back is also the German steel mill attack, right? This is where the adversary were able to access the office network using an APT or targeted attack, and then they were able to gain privilege, right, across to the industrial environment, right, and be able to basically shut down many of these systems, which also have significant impact on some of the manufacturers of this meal. And then you can see here in 2015, we have this black energy, or what people call the Ukraine power grid attack. And this is a very interesting, but also I would say how it compromised the industrial OT network, right? The malware actually came through the corporate IT networks on the IT side, via phishing email, right? And basically an employee basically click on that email, and then it was able to basically drop a malware into the system, and then from there it was able to perform lateral movement across from the IT over to the OT environment, right? And it spent a couple weeks, in the supervisory level, and from there they were able to gain, additional, privilege, and it make its way down to the control level and was able to compromise many of the, controls, process control system or some of the HMI machine, and really kind of causing basically, a bunch of system there to be basically down in the operation of this environment. And then one of the very recent one, also back in 2017, is the Triconics, or the Triton attack, right? And this is very much a malware that attack factories SIS system. And what this does is basically it create a bunch of plant systems to be tripped, and that also have a significant impact on that environment. And then I think back in 2018, last year, what many of you have seen or hear is that TSMC, one of the largest chip fabrication company, was also being compromised by a ransomware, right? And that was able to basically gain access to many of the system by this particular ransomware, which is the WannaCry, and their plant was shut down for many days and weeks as well. So as you can see, right, some of these are real world example and real world attacks that is happening, and we will probably see these more and more. Very similar on the IT side as well. Rich, next slide. I'll pass this back to you.
All right. So again, referencing the 2019 SANS Institute survey, the question was asked, what are the leading business concerns? And from an OT perspective, ensuring reliability and availability of the control systems remained #1 since their previous study in 2017, followed by ensuring health and safety of employees, and then in third place, lowering risk or improving security. So as you can see, that's maybe a difference in perspective from traditional IT, where their confidentiality of data might be there first. When we take a look across, what industries have been targeted, as we've seen in some previous slides, the energy industry has been particularly targeted, and while you can see from 2016 to 2017, that has gone down slightly, mainly because of the practices that were put in place. Critical manufacturing also remains a big target, and that's actually on the rise. So another thing we want to bring up is that cybersecurity is not something you buy or something that you get. It's really considered like a lifestyle or a continuous improvement process that has 3 main pillars. So people, process, and technology. So people, making sure that your staff is trained and aware of the types of threats that could potentially face them. Making sure that your staff has the professional skills and qualifications to be able to deploy, manage, and monitor the networks, and making sure you have access to competent resources. From a process standpoint, making sure that you've got the management systems, the government policies and frameworks, of course, based on best practices, and that there is an audit to make sure that you're actually following those processes. So most of today's webinar, we're going to talk about the technology aspect of this. So looking at that you're designing your system, utilizing technologies that are tested, verified, and validated, and that that your technology deployment has the right people, support, and processes behind them. So with that brings us to our first poll question. So of the three elements that we just talked about, people, process, or technology, which element do you consider to be the greatest risk for compromise to your OT control systems? So people, process, or technology. So it looks like the voting's starting to pick up here. We'll give it a couple more seconds here for everyone to register their vote. All right, and let's take a look at the poll results here. So 71% of you see people as the number one, followed by technology at 20% and process at about 9%. So that's pretty close to what we've seen. We'll go back to the slides here, and I'll share the survey results from the SANS Institute survey. So the SANS Institute, a little bit lower on people, but still more than half at 62%. Saw people as the major risk, followed by 21%. So about the same percentages as we had here for technology. And then process making up around 14%. So clearly, most everyone sees people as the biggest risk. So moving on, part of enhancing security, it helps to have a little bit of an understanding of how attackers, the anatomy of an attack. What are the elements of it? How are people actually behaving as they attack a system? So we've kind of simplified this and broke it down into three stages of the attacking process. So the first one being to seek information. And so that's really looking for a first point of attack or an entry point into your network or OT systems. So that could be devices that have the default username and passwords as shipped from the manufacturers, or you've got an exposed MAC or IP address out on the internet. You've left service ports available. You've got a non-secure, a legacy PLC or HMI that's not securable, or you've got known vulnerabilities that haven't been patched. So we're going to talk a little bit about device level security as one of the major things that you can do to try and minimize those weak entry points. Secondly, once a hacker gets into the system through that first point of attack, then they're typically trying to scan the network to look for what else is on the network that's worth attacking. Where can I do some damage, or what assets can I lock down and potentially hold for ransom? So they're looking to increase their credentials within the system to gain access to more and more devices and more areas of the network. And then finally, once they've identified an attack target, they've gotten the credentials that they need to actually interact with that target. Then they would start to commence the attack. So often this process can take days, weeks, or months from that initial point of attack. So it's important that you've got some network level security to minimize the ability for an attacker to go throughout your entire network from a single point of entry. and you want to be monitoring and managing that network to make sure that you can look for signs that somebody's in there poking around and trying to gain access to further assets. So with that, I think I'll turn things over to Richard, and you can talk in a little bit more detail about some of the specific attack vectors that are common out there.
Thanks, Rich. So I think, as you many of are aware, right? As more and more devices are connected to the enterprise network and also the OT networks, right? We are definitely going to see more and more threat vectors coming in through, right? And this is just one good example of an attack vector, and we see this quite often. Is typically the adversary will try to gain access from the IT side, right, on the business network first, right? Because that seems to be much more simple, easy to be able to gain the credential and gain access to some vulnerable system. Even though on the IT side, everyone has been pretty secure, but this seems to be a very obvious attack vector, is to the business networks, and then from there, right, it will make its way into the control system, and then from there down to the field device. So this is a very good example where I mentioned early on one of the Ukraine attacks, right, where you basically see this particular attack vector being utilized and be able to gain access to the other side of the OT network. Now, in addition to that, threat vector, we also see many other type of ICS attack vectors by the adversary, right? And these are some of the examples that we have seen coming through as we monitor, the different, environment and different customer sites. So you can see here, attack can be coming from the protocol, because some of this protocol, have been around for many years, and sometimes it's not encrypted, right? It's basically it's pure, and you can see everything. So, and very vulnerable. So that's a communication protocol is a very was a big area of attack. Web application attack, right? That's also important to recognize that as well, as more and more devices start to connect to the as the internet. Wireless attack, I think in order to gain access to some of this network, right, and also in many of the OT environment, organizations start to basically create their own little wireless access point to allow connectivity into the OT networks, and that's also will become an attack vector for the adversary. Software application, right? Many of the software application, as Rich mentioned earlier, right, in the industrial side, even from a application or from operating system or perspective, right? Many of these systems and application basically are very old, right? And they don't particularly get any patch or update or service, right? And so many of these applications are also very vulnerable to attack or being taken advantage by the adversary. And then the server side is also an area that people would like to see, because that's where all the data is, right? And this is where all the important information and your critical data in information, and so that's also a very vulnerable area for the attacker also. And then last but not least, right, you have those field devices, as Rich mentioned earlier, right? Many of these field devices basically is a prime target for the attacker, right? Because many of the systems are definitely does not have a secure and never built with security in mind, right? So you're gonna see default password that have been around for 10 to 15 years, right? You're gonna see vulnerability in the system. You're gonna see fairly simple password like 1, 2, 3 or password and stuff like that to gain access to the field device. So it's not just on the IT side, but also on the operational technology environment on the ICS side. We do see many attack vectors that we have to be aware of, and we need to make sure that we secure those attack vectors. Next. Yeah, so we already gone through this, but I want to provide people an example, right? To let them know that, as you can see for this particular example, as I mentioned earlier, right, the attack are really happening on the, from the internet, right? And you need to be to recognize this, and there need to be a level of collaboration between the IT and the OT networks, right? And to address this type of cybersecurity issue, right? If you only rely on the IT side and they don't have a collaboration or communication with the OT organization, especially the operational engineer, you can potentially miss some of this attack, right? And so, in order for you as an organization to be able to address some of this concern, the relationship between the IT engineering and also the OT engineering, they have to come together, be able to have a better understanding as to how the attack will potentially come in and how they can work together to address some of these concerns. Because this is no longer just an IT issue or an OT issue, right? It's a collaboration between these two organizations. So that's the point I'm trying to make here. Next slide. Right, and then in terms of this Triton or the Triconics attack, right? This is important to recognize that that there is a lot of challenge in terms of skill set, in terms of domain knowledge, and the domain expertise, and also the collaboration, right? And as you can see, right, this particular attack was very difficult for the company to actually identify, because there wasn't a lot of collaboration between the IT OT organization. As you can see here, right, the attack was started in June of 2017, and some plan what actually tripped, but they could not, and no one really identified that was a malware attack, right? And then what happened was that the company actually sent that device back to the device manufacturer, in this case Schneider Electric, and they looked at the device and they did not find any issue. They shipped that back to the company. They put that back in the operation, and then guess what? Right, in August 2017, a couple months later, the system was basically tripped again, and and they were now finally figure out that that was a malware attack, right? So what I'm trying to point this here is that you really need to have that domain knowledge across both the IT and OT side, and they need to work together to be able to address some of this concern, right? Because sometimes the IT person does not necessarily want to talk to the OT people, and vice versa, right? So having this collaboration, I think it will be a good, way to really address the overall cybersecurity across the IT and OT, right? Rich?
Thank you, Richard. So with that, we'd like to move on and talk a little bit about some of the differences in perspective with OT versus IT, or the industrial versus enterprise security. So from an IT perspective, typically the #1 business priority is confidentiality of data, followed by data integrity. They're typically protecting Windows computers and servers, and that equipment resides in a fairly well temperature controlled, air conditioned room. Whereas on the OT side, as we mentioned earlier, the #1 priority is availability, keeping the process running. Very little tolerance for downtime. So in addition to that, the challenge is you're protecting industrial devices like PLCs and HMIs, and many of these devices could be decades or more old. And to make things even worse, these components reside in fairly harsh environments, extreme temperatures, high vibration, shock, electromagnetic noise. So simply taking an IT product and putting it out there doesn't necessarily solve the problem. So let's dive a little deeper on availability. So typically these industrial control systems are what's running the business process. So it's if this system goes down, the equipment that it drives goes down, and the company stops making money. So there's a lot of incentive to keep things running. And so that makes it difficult from the standpoint of delivering security patches. In many cases, people are afraid to deploy patches because they might break the system, or just the time it takes to shut the system down and deploy the patches could be a disruption. Unlike an IT environment where maybe every Tuesday morning your laptop runs a security update from Microsoft, they're very hesitant to allow that type of thing to happen. A, for the time it takes, and B, that could jeopardize the process. Also, with use of firewalls, where on an IT side it might be common to take a suspect file or command and quarantine it for a period of time until they can determine whether or not it's safe. Very little of that happening out on the factory floor because of the fear that you're blocking a critical control or safety command. So very, very protective of anything that might potentially disrupt operations. Second, we see on the IT side, typically equipment is rotated through or replaced, every 2 to 3, maybe on the outside 5 years, but you're typically working with fairly recent technology, stuff that's still supported by the manufacturers as far as deploying patches. On the industrial side, it's common to see brand new equipment sitting right next to 50-year-old equipment. And in many cases, the technologies, the manufacturers no longer support that equipment. There aren't adequate replacements available today. And so the process keeps running, and until that piece of hardware dies, they're going to keep relying on it. And many of those, as Richard pointed out earlier, don't have security in mind when they were designed and deployed. And finally, the environment, so extreme temperatures, an oil rig sitting at, or, an oil platform in Saudi Arabia at 100 and some odd degrees sitting in the sun, high shock, high vibration, an oil rig sitting in Alaska, very low temperatures. So the equipment that's used has to be able to survive and thrive in those 24/7 environments. So now we've talked about some of the challenges. We'll move on to some of the gaps and vulnerabilities that we see in industrial control systems. So here's a handful of the ones that we see most often. So much like on the IT side, you have shadow IT, well, we have shadow OT. So as Richard pointed out earlier, that could be something simple like an employee with good intentions setting up a wireless access point to give easier access to the control systems without having the understanding of how to safely deploy a wireless network. That could also be a contractor or an equipment supplier putting a gateway in so that they can access their piece of the piece of equipment that's out there on the floor for diagnostic or maintenance or troubleshooting, and that could be deployed in such a way where they not only have access to the piece of equipment that they're trying to work with on your behalf, but also the broader network. Lack of authentication. There was a recent Inspector General of the United States put out a report with traffic cabinets stating that 51% of the audited traffic cabinets across the United States had the default username and password still in place on those devices. To make things worse, you could buy a master key for a traffic cabinet on eBay for $8. So that basically means anybody can go online to the manufacturer's website, find out what the default username and password is, and just plug in and try it and see if it works. And so that's a big vulnerability. Richard also meant insecure protocols. So I think Modbus is one of the more common ones that's out there that, you know, when that protocol was designed, security wasn't really a top of mind issue. So the protocol itself does not have security features built into it. So that can cause a vulnerability there. Unpatched systems, we see a lot of older equipment, Windows 95 or earlier PCs out on the factory floor running various processes. Patches may not be available, or as I mentioned earlier, you know, people are afraid to deploy them because they might break the process. Lack of security design features we talked about. Insecure third-party applications. So a lot of homebrew applications out there that you know, the people may not have the skills or focus to make sure that they're secure. Is there anything you'd like to add on this slide, Richard?
Yeah, maybe the only comment I would add is on the malware threat, right? And, you know, like APT, ransomware attacks and some of those, you know, I mean, you know, we always think about, you know, the OT environment is secure, and, you know, we don't worry about, you know, malware attacks and stuff like that. And, you know, some of the example that I mentioned and Rich mentioned before, right? Those are your typical, you know, APT ransomware attack. And traditionally, we only think about those on the IT side, but now we are seeing more and more of those attacks are actually really happening right on the OT networks, right? And those are just some good examples. So I want to caution people to also look at that, you know, malware attacks like this are no longer just only for the IT side, but also very much, you know, it's going to come across the OT networks, and we already see that through the many connectivities and the different attack vectors that we've been monitoring over the last couple of years.
Great, thank you. So again, this was actually, again, a question from the SANS Institute survey, but looking at what are the top threats as perceived by control system operators. And so the number one was clearly devices or things that can't protect themselves that are on the network, followed by internal threats or accidental. The person that plugs a laptop into a device and accidentally introduces malware or interrupts a control network system. And third would be the growing threat of external threats from, and this could be, and this is really looking at like supply chain or partnerships. So that would be somebody that's coming into your network on your behalf, such as an equipment supplier or an integrator that accidentally introduces a threat. And then fourth, that external threat from hackers or nation states. So diving into that number one issue of devices that can't protect themselves. So we're really talking about again, some of the older equipment that may not have the security features, where you don't have the ability to deploy or enforce a strong password, where you don't have the ability to encrypt the connection to the management console, and passwords and usernames are then sent over plain text on the network. Incomplete event logs. So a study done by the Department of Homeland Security and vulnerabilities that were reported, almost a third of them, people still did not a year later know what the root cause of the breach was. And that's often due to the fact that they're not setting up event alerts and keeping proper logs to really be able to track the activity on the network. Unsecure maintenance mechanisms. So again, you've got vendors setting up backdoors into your network in order to access and monitor or maintain equipment, often on your behalf, that isn't set up properly to secure your network. And finally, unpatched or unpatchable vulnerabilities. When we look at unsecure network design, what we're really talking about is, in many cases, we see plant networks that are one big flat layer 2 network, no segmentation. So anyone that gains access to the network has access to the entire network. Same thing with devices, that if you've got the same username and password on one device and somebody gains access to that, they have access to all your devices. Again, as the IT and OT networks are connected, I think Richard covered a couple examples where that lack of understanding of the OT environment and the lack of collaboration between IT and OT caused a vulnerability to get into the control system undetected. And then remote access, whether that's site-to-site remote access within your own company, or access that you're providing to maybe some of your maintenance technicians to get into the equipment after hours remotely, or whether that's a vendor that's doing some troubleshooting or maintenance on your behalf, making sure that you've got that the connections into your system are authorized, that the people using them are also authorized, and you're validating that, and then that those connections are encrypted so that the information that is sent remote is not interceptable. And the third thing we really see is a lack of visibility. And so we talked about shadow OT, insufficient event monitoring, whether that's setting up alerts such as a firewall rule that's being violated. You kind of want to know that that's happening before that hacker is successful at getting through. And then making sure you're keeping good logging of the security events, such as device configurations, who's logging in, where and when, different types of traffic that might be abnormal within the network. Helps you, A, find the root cause quickly, get you back up and running, as well as identify breaches in the future that and fix those. So the question we typically get from a lot of customers that are starting their journey on cybersecurity is, where do I start? And we typically want to point them towards the standards. So here's a handful of the top standards that we see in the U.S. So ISA 99, also known as IEC 62443, is one of the top standards. In the power automation, NERC-CIP, we see pretty commonly. And then for critical infrastructure, NIST 800, that family of standards. And then marine, and it has their own standards, as well as IT security, typically the ISO 27000 series. So we see a lot of these standards being referenced. The chart on the left really just shows that there's a lot of overlap between these standards. So in the absence of a clear standard that's prevalent in your specific industry, really just picking one that one of the top ones and starting to work with it is important. So that brings us to our next poll question. So which cybersecurity standards, regulations, or best practices do you use to map to your OT control systems? So the first would be the NIST 800 family. So NIST 800 cybersecurity framework, or the more specific NIST 853 or NIST 882. I think 53 is targeting critical infrastructure, 82 is targeting industrial control systems. The ISO 27000 series, which is more common in IT. The ISA or IEC 62443, or also known as ISA 99 standard. Or the CIS, critical security controls, or if you're looking at a different one, the others. So put your votes in, and we'll take a look at the results here. So 38% IEC 62443, followed by other or none, and then NIST 800 looks like the third place there. So let's go back to the slides here, and I'll share part of the SON survey. So I think a couple of things to note here that the ones we had up there are some of the top standards. But looking at 2 or more years ago, you could see that adoption of standards was fairly low, and that's been increasing pretty significantly to within the last 3 months. Almost 60% of people are deploying one of these standards, with the top 2 being 62443 or NIST 800. So standards can be kind of complicated. Some of them are 1,000 pages or more to read. But they all pretty much look at, they start with a process of doing a risk assessment. So what's the probability of a threat, or what are the vulnerabilities I have, and what are the potential consequences of a breach? So then based on that risk, what's an appropriate level of security? And balancing that reduction of risk with the cost associated with deploying that. This is an example from 62443 where they've defined 4 levels of security, and based on your situation, you choose the security level that's most appropriate based on the risk you're willing to tolerate. We see most people targeting somewhere around security level 2 as being a fairly common target. So with that, I've got one more poll question. So how would you most closely describe how you're staffing your current cybersecurity initiatives? So are you relying on outside expertise, such as a security consultant or an industrial control system supplier or integrator? Do you have somebody who has part-time responsibility for the industrial control system security? Maybe you've got a full-time person dedicated to ICS security, or even a cyber ops group responsible for security. So just pick the one that most closely matches your situation. And, all right. So it looks like 35% have someone who's part-time responsible for security, with another 30% outsourcing it. So that pretty closely matches what we see. Outside of oil and gas and probably power, those 2 vertical markets tend to have more advanced cybersecurity requirements, either due to regulation or due to the actual catastrophic nature of a breach. So that's going to take us to this is a maturity model developed by the ARC advisory group that really talks about where do people start, what are kind of the steps that they take on their journey towards securing their industrial control systems. And at the top, it really kind of maps to what type of staff do you really need to effectively deploy and manage and maintain these systems? So, starting on the left, typically people that are outsourcing, they'll bring somebody in, do an audit, look at the physical security, take asset inventory, look at the configuration of the devices and harden the configurations, deploy patches. Then they'll start to move towards deploying firewalls and access control, and then moving more towards a defense in depth with zone firewalls and deploying some whitelisting. At that point, you need some personnel to be looking at this on a regular basis. So, if most people are at that part-time plant level ICS staff, this is probably where you're at, or what's possible. When you move beyond that into SIEM, incident management, anomaly and breach detection, you really need full-time staff or even a team to manage that. Richard, is there anything you'd like to add on this slide?
No, I think you covered. I think we're good.
Okay. So keeping that in mind, we really look at these three items here as kind of the things we really want to look at. So starting with that device security, hardening the devices to the best of their ability, maybe even looking at some of the more vulnerable equipment and replacing it or upgrading it with more current technology. And then looking at your network and doing some things to segment the network to try and make it harder for somebody to move around the network once they get in. And third, provide that security management or visibility to what's going on from a security standpoint. So looking at those things in a little more depth, again, device hardening, a lot of these are things that a consultant can come in and do for you, or you could do with part-time employees, is changing account passwords, using stronger passwords, disabling the unused physical and network service ports, making sure that you're encrypting critical files and encrypting connections to the management interfaces, whitelisting and allowing only permitted IP or MAC addresses to the network, protecting critical devices with industrial firewalls, and executing periodic security patches. When we're looking at secure network infrastructure, we're really looking at three things. We talked about segmenting the network so that, similar to a medieval castle, you've got the moat, you've got the outer wall, the inner wall, and then the tower. So your critical assets are behind multiple defenses. Same idea here. Segment your network into smaller logical zones. Secondly, manage that communication between those zones by using whitelisting and filtering data using firewalls. And third, secure remote access, making sure that the remote access is authorized, the people using it are authorized, and the connections are encrypted. And then finally, security management, looking at taking an accurate inventory of the assets connected to the network, looking at your configurations, backing those up so that you have good copies, looking to do device security policy audits, and then security event detection and logging. And I think one more thing that we're particularly seeing more and more of is, on the IT side, it's pretty common for suppliers to have robust systems and processes around vulnerability management. On the OT side, we don't see that is true across all suppliers. So make sure you're working with somebody that's got a legitimate process around monitoring to see vulnerabilities in their products, responding to researchers as they find vulnerabilities, and publishing either instructions on how to mitigate those vulnerabilities or firmware patches to mitigate those vulnerabilities. So with that, I think the last thing we want to do here is kind of wrap up with just, here are some of the things that Moxa and Trend Micro can help you with if you're looking to increase the security on your network. So first, at the device security level, so some intrusion protection and intrusion detection solutions, application whitelisting, antivirus, and embedding the IEC 62443 features into the product. Second would be network access, so limiting access to the network either through access control lists or port security. Secure infrastructure, so data encryption, next generation firewalls, secure routers, and secure remote access solutions. Fourth, security management, network management with security views that help you manage, implement, and monitor your configurations, as well as OT security consoles to give you that one pane of glass to see all of the security-related events that are happening on your network. And finally, taking a holistic approach. So Moxa's cybersecurity response team to respond with rapid patches to vulnerabilities as they're identified. And then, Richard, maybe you want to talk about Trend Micro's zero-day initiative?
Yeah, just a quick comment on that. I think the zero-day initiative from Trend Micro, I think many of you are aware that we are very focused on basically, working with probably 2,000 or 3,000 security researchers around the world, right? And we typically, work with them to identify many of the vulnerability across the different type of device, if it's on the IT side or the OT type of device. And we work with some of these manufacturers to make sure they get patches, update and quickly into some of this environment. Now, in many cases, when the vulnerabilities are reported, they might be like, 120 days or even, 3 months, 3 to 6 months out. And if, the device manufacturer or the platform provider does not have a patches available, then we can also actually create what we call virtual patches, right? And that virtual patches can be made available across all the Trend Micro and Moxa product as well. And so just something to add on that, from a zero-day perspective. But yeah, we are one of the largest, I would say, bounty, program out there for the, security researcher, and we probably discovered hundreds and thousands of, basically vulnerability way before, any of this actually get reported to the customer or to the vendors or to the field. So.
All right, thank you, Richard.
Yeah, maybe one thing I want to cover here also is that I don't know in the, operation on the OT side of the world, right? As we have this connectivity between IT and OT, we are starting to see more and more, people in organization are sending telemetries and data, across the OT network all the way to the cloud and leveraging, cloud infrastructure such as Azure or AWS or Google, right, to kind of perform all the analytics in all the, collaboration and be able to make decisions, through that, a cloud environment. So that is also another area that, we, both our organizations are actually working to address it. And I think, as you are aware, Trend Micro is very much the market leader in the cloud security space as well. So securing the cloud, some of the workload in those virtualization environments also one of the key point in terms of the holistic solution.
Very good point. All right, so just to wrap up, we've got a few takeaways here. So first, industrial cybersecurity does directly impact safety and equipment availability, as we've seen in some of the examples. It's important to approach cybersecurity from a holistic approach, considering people, process, and technology, making sure you're getting your people the education and training for both IT and OT around the technologies and threats, deploying consistent policies and procedures based on standards and best practices, and then auditing against those, and establishing a solid foundation for the industrial control system security through secure, hardening the devices, implementing a defense in-depth network architecture, and using tools to manage and monitor the network security. So with that, I know we're running a little long here, Scott. Do we have any questions that we want to address in the time we have left?
Yeah, thanks, Rich. We do. We have a few, but it looks like we have time for about one. So why don't we just get that one in? So the question is, you referenced NIST 800 and IEC 62443 as the two most common industrial cybersecurity standards. Can you elaborate on some of the differences between the two and why I might choose one over the other?
Sure, I'll take a stab at that, and then Richard, if you have anything to add, we'll move on from there. So I think the NIST 800 cybersecurity framework is kind of a high-level view of, how to approach cybersecurity. the framework itself actually references IEC 62443 as a reference. So if you look at NIST 800 framework, it's really defining outcomes or objectives that you're trying to achieve, whereas 62443 is going to go into more detail as far as how to get that, what technologies and techniques to use, and how to determine how much security is appropriate given your situation.
Yeah,
Richard, do you have anything to add there?
Yeah, let me just add a couple comments here. So I think to Rich's point, right? Traditionally, I would say the NIST 800 and the 53 and also was really more designed and as a framework for the IT environment, right? And only I think over recently they started to add, I would say, you know, kind of additional a module for the industrial and OT side and how to, you know, come out with the best practice for the critical infrastructure or some of the OT environment. So that's one big thing, because traditional I look at that as more of a IT kind of guideline, and then on the 800 or on the ISA 99 or people call it IEC 62442 standard, that traditionally also have been very focused on the I guess the ICS environment. But I think, as Rich mentioned, right, most of these are really kind of reference each other when it comes to the type of security control that people need to use and what type of framework to use. So, all these standards are now actually are very much, I think, can be used across, any industry, right? People used to think about this standard as only for ICS or only for IT, but I think, as many of us actually sit in some of this work group, we're trying to, make sure that this type of standard can be, reference each other and can come together, because they are very much, talk about the same thing. And, you just have to start on one standard and use that, and then you can reference to the other standards. So that's the only thing I want to comment. And, the standard out there, like, IEC 62443 standard, there are many working group out there that you can actually go into the ISA website, right? And you can actually go down the list, and you can actually be able to read through it and see and figure out which standard that actually will best meet your particular requirement on your industry as well. So there's a lot of this information out there.
Great. Okay. Thanks, Richard. This is a topic we can go on and on about. We're out of time for today. I do want to thank both Richards for their expertise in sharing that today. If anyone in the audience still has questions or needs help on an issue related to cybersecurity, please feel free to reach out to us directly at usa@moxa.com. Thanks again, everyone, for joining, and have a great rest of your day.
Thanks.
Thank you.